So let's start. Derivative. We are using derivatives since school days.
Wait, what? School days? I have heard this word derivative in 11th standard, I guess.
Okay, let me ask you something. I have a graph. You can see this line. Can you find the slope of this line?
Yes, sure. It is a straight line passing through origin and coordinates 1, 1. So clearly its slope is 1. We can use slope formula for coordinates. We can also use that angle of inclination formula. But what it has to do with derivatives?
Let me explain. Actually, derivative is a rate of change of any function with respect to a variable. Basically, it is rate of change of some function over the period of time or space. Here you found slope of a line, which is nothing but rate of change. Or for better understanding, we can say that by seeing small portion of that line, we can guess how this line will behave in space.
Yes, got the point. We have used the concept of derivative but never used this term.
Yes. Now, if you are saying that you understood the topic, let me ask you a question. See this picture. Assume that you are a mountaineer. So, which mountain is easier to climb, first or second?
Yes, of course, I will go for shorter one. It has little less height and also less length to travel.
What about the steepness then?
What is steepness?
Along with height, there are many other factors to consider when you are climbing a mountain. Let us consider two graphs of a line. Now, steepness is nothing but slope of a line. So, let's find the slope of two graphs. Slope of first graph is equal to vertical line upon horizontal line, which is also equal to tan theta 1, which is equal to 1. Okay. Now, slope of second graph is equal to vertical line upon horizontal line, which is also equal to tan theta 2 and which is equal to 1.5. So, now higher the slope, higher the steepness. Implies that harder to climb a mountain. Now, tell me which is more steeper?
Yes, first one is steeper and difficult to climb. I will go for second one.
Now, let me give you some formula of differentiation.
Yes, I got all the formulas, but I remember learning formulas is not the main thing in differentiation. It's how you are going to apply them. And for this, you need a good hold on differential equations and numericals. So you need to practice hard. Now, let me ask you a question. I give you one circle with radius 4 cm and now I am increasing the radius of the circle. And can you tell me how will it affect the area of the circle?
Surely it will increase.
Yeah, good. But can you give me rate of change?
We have a formula of area. A is equal to pi r square. Now, if I differentiate it with respect to r, pi is a constant. So, we have to derivate r square. And by the formula, derivative of x raised to n is equal to n into x raised to n minus 1. So, derivative of r square is 2r. So, differentiation of our area with respect to radius is equal to 2 pi r. Represents the rate of change of our area when radius is r centimeter.
Yes, great, on the mark. But one last question from my side. Is it applicable to all the functions or there are some functions to which we can't apply these rules of differentiation?
Yes, there are many like mod x at point 0, it gives different values when we approach from different